kind of sister part of the Microsoft MVP family, and today I am going to talk to you about performance in the JavaScript era. So we live in some very exciting times, both as web developers and in the world at large. After all, things that we didn't think were going to happen about 5 years ago. Britain is leaving the European Union. I'm really sorry on behalf of the 48% that did not vote for that decision. It is economic suicide. SQL Server runs on Linux. Linus Torvalds, when he first invented Linux, was interviewed by a magazine and was asked, what is the key milestone for Linux? What's the goal? And he said, the day that Microsoft makes products for Linux, I have won. And he has. Donald Trump is somehow still the president of the United States, although Robert Mueller is slowly closing that down. Hopefully not for much longer, otherwise we're all going to die in thermonuclear war. .NET and ASP.NET are open source. Who would imagine when it was invented to replace COM+? Remember those days, boys and girls? Yes. And Germany are out of the World Cup for the first time in 80 years in the first round, and on top of that, England won a penalty shootout. What is going on? And JavaScript somehow is a popular and widely used server-side programming language. I have no idea. We are living in a parallel universe, but this is what we have. So one I want to start by asking is, oh, I'm sorry, that's from my job writing someone else's tweet. What does web performance really mean? So if I were to throw this question out to you, and I were to ask you to raise your hands, when I say the words web performance, what are the first things you think of? Any takers? You're not allowed, you've already seen this last night. Any takers? What would you think of? Latency. Latency, okay, network latency, good start. Anything else? No? All right, well, I will nail it down to what I think are three key areas. The HTTP request itself, how many there are, and how large they are. Server render, how long it takes to actually spit data out, whether that's an API endpoint or whether that's a Razor view. And finally, browser, load, and paint. These are three distinct areas that we can measure individual performance in our entire websites and web applications. I'm going to focus on the first two, the request and server render. I'm less of an expert in terms of CSS and rendering engine expertise. If you want to talk details about that, follow Leah Veru on Twitter. She works for the CSS working group for the W3C, or look up Rachel Andrew, who I believe is based out of Manchester, and she knows a ton about HTML5 and JavaScript APIs and runtimes. So I'm going to focus predominantly on those first two. There's a little bit about some performance stuff in the browser, but not a huge amount. All right, so firstly, how do we measure performance? If we're going to talk about improving performance, what we need to know, obviously, where we're starting from. So, tools that we use on the front end, we've got YSlow with Phantom.js. How many people are familiar with YSlow? A couple of people. OK, excellent. Next, we have PageSpeed Insights, now known as Lighthouse. How many people are familiar with that? Nobody. Brilliant. And WebpageTest, which is an online hosted service. Again, blank faces. OK, well, we're going to demo all three of them today and show exactly why each one is beneficial when measuring your website and your web app performance. And then on the server side, we've got JMeter. Anybody come across JMeter? A couple of people, okay. And then we've got Miniprofiler and Glimpse. I'm mostly a .NET developer. I'm assuming that a lot of people here are kind of .NET related. Yeah, most people. So most of you will come across one of these. I'm going to cover Miniprofiler more than Glimpse, because I don't actually have hands-on experience with Glimpse. And Miniprofiler is built by the guys at Stack Exchange. They use it on Stack Overflow. It's super awesome. You're going to love the demo. And of course, custom logging. So I don't need to tell you how to use Log4net and Starter System Diagnostics, Stopwatch. You all know how to do that. So without further ado, let us step into some demos. And now this site was online earlier this week, and then it got taken down on Monday by a hacker. So this is a local version that I'm running. And you'll notice in the left, that's the Miniprofiler UI, which I'll come to later. This is verbier.com. It sucks as a website. It's not responsive. It has not been optimized. It does not have minified CSS or JavaScript. It is not mobile friendly. It does appallingly at SEO. No one has invested any money into this thing, which is why I can demonstrate it as a completely brilliant example of everything you shouldn't do with a website. So we're going to start, if this works. No, that's the wrong screen. There's my mouse. Good. All right, so up here, top right, you see that little blue icon? That's YSlow. It's a browser extension built by the Yahoo team. During the days when they were still doing the UE JavaScript framework. Does anyone remember that? Yeah, the one that died when jQuery took over everything. Anyway, out of some of the interesting front-end stuff that the Yahoo engineering team did is they developed this. And this basically runs a number of tests against your DOM and your CSS and your JavaScript. It checks things like HTTP headers and tells you, it gives you a grade basically out of 100. So unlike your school teacher, it won't put you in detention. If you do use this and you don't improve on it, your boss might. So without further ado, let's see how badly this one does. And I've done some few improvements on this locally, but trust, most of this, apart from I've done one CSS minification, everything else was basically up there on Monday. So let's take a look at what it shows us. Make fewer HTTP requests. There are 21 external JavaScripts. Try combining them into one. Obviously, we want to reduce the number of HTTP requests we want to make to help improve the speed at which stuff starts actually getting painted in the browser. So 21 JavaScripts, that's a hell of a lot. Most of that's probably things like tracking cookies as well, which is a particular pain in the neck. So who here does not do CSS and JS minification? No one's brave enough to put their hand up? Okay, good. Excellent. Nice to see. So I'm not going to recommend any particular minification tool because if any of you have worked with Node in any way, shape, or form, you'll know that you can do this and go to npm and you can search Minify, and there are a total of how many packages can actually do this for you? 1,761 separate Node packages built by people that will minify your CSS and JavaScript. So I'm not going to tell you which one. Go find one, go use one. So let's go back to YSLAM and see what else it can tell us about this. Use a content delivery network. Now, this is an interesting thing. Even for small sites, one of the websites I used to work on was called the Formula E website. Is anyone familiar with motorsport at all? No? Okay, it's electric class Formula 1, basically. And it's a sister championship. They had a load of ex-F1 drivers race their first season, and now I think they're in their third or fourth season. It's a pretty kick-ass sport. I'm slightly biased because I basically helped build the entire website infrastructure. But one of the first things we did when I came in and they were struggling to even handle 10,000 requests was I discovered 4.5 gig. To basically save requests on the actual web server, we moved it over to Amazon S3 storage. 5 gig, completely free S3 storage. And if you whack CloudFront on top of it, the CDN, 50 gig of free data transfers, okay? Even if you're running a tiny site, right? You could be running your personal blog, move your stuff onto a CDN. There's a reason for this. If you move it to a separate subdomain, the cookies set for your primary domain won't get sent. As a result, your requests are smaller, and so are your responses. So we're talking about not just reducing the number of requests, but the actual size of the requests too. So use a CDN. It's very beneficial. I think Azure charges something like 0.3 cents per gigabyte per month. So even moving 4.5 gigs worth of media would cost what? 1.2, 1.5 cents per month? That's fractional. It's not even a stick of gum in a year. You know, you kind of use the analogy for things like app subscriptions. Oh, it's not even the price of a cup of coffee. This isn't the price of Azure storage wouldn't even be the price of a cup of coffee over 10 years, right? It's that cheap. So there's no excuse you shouldn't be using it. So what else do we have? Add expiry headers. This is a good one. Now, 41 static components without a far future expiration date. As part of the HTTP spec, obviously you can send various headers before you send the body, and one of those is the expiry header. By not having an expiry header, the browser doesn't know to be able to cache this, basically, and as a result, it will constantly re-download every single resource every single time. And I will demonstrate this quite neatly by using Chrome DevTools. And we go to network. All right, so I'm going to disable the cache on the first go and call a reload. And now it decides to be slow. There we go. Right, number of requests down in the bottom. I'm just going to let that finish. Right, that's down at 74 already. 75. All right, let's call it at 75. OK, I'm now going to uncheck disable cache, and I'm going to check preserve logs. So you're going to see the difference between that first count and the second count. You should be able to work out how many things are being downloaded. Let's rerun it. and we go back through. And now we're down at 162. So that's even more requests than the first time. Now, I can probably guarantee that's partly because of Mini Profiler, but I can absolutely guarantee you every single image, CSS, and JavaScript has been re-downloaded again, even though I unchecked the box that said disable cache. That means there is no browser caching happening because it does not know about it because there's no expiry header in there. Use expiry headers. They're dead easy to implement. It's one line in your web config. If you're doing CDN and blob storage, right, you can even do PowerShell to actually set metadata that then gets fed through to your CDN as extra headers. So, and there's plenty of PowerShell documentation out there that will tell you how to be able to do that. So, use your expiry header. What else can YSlow tell us? Let's see. Let's go down the list. Okay, put CSS at the top. Now, this is an interesting one. The reason you want to put the CSS at the top of the file is because if you don't put it at the top of the file, then basically the browser has to interpret the DOM, then it has to load your CSS, and then it has to paint, right? So you're adding extra latency. If you put it at the top, those are the first requests that get handled, right? If you put it in the head. There was a silly mistake in this site, which I fixed on this local one, where, you know the Facebook like button, you know, it's like a little div and a script that you just copy and paste if you want the like button on your site, you know, from the developer section? Right. Previously, I go view source. There we go, and I will just zoom it in down there. Right, there we go, that little div and that script there. Now that previously had been copied and pasted up into the header. Why is this a problem? The moment the browser sees a div, it ends the header. All the JavaScript and the CSS, 9 different CSS files, 21 different JavaScripts, were all being loaded into the body, as a result delaying paint further, just because someone copied and pasted a block of code in the wrong freaking place, right? Be careful where you copy and paste your things, basically. So, but that one in particular that we're looking at, Shadowbox, that's actually being loaded by a jQuery plugin, so we'll come back to jQuery. Speaking of which, if anybody is still using jQuery, don't. It's horrible in terms of performance. Right, what else do we have? Minify, CSS, and JavaScript. We've already covered this. What else do we have? Configure entity tags. Now, this is an interesting part of the HTTP spec. Has anybody heard of e-tags before? One, well, I know, yeah, you're not allowed to put your hand up for any of this. He saw this last night. Right, 1, 2, 3. Okay, for those that don't know, an e-tag is supposed to be a kind of representation, a stamp that, a bit like, you know, how you have the integrity section on a script include. It's supposed to be some sort of identifier that says that these file contents are valid at this point in time. So you'd use something maybe like an MD5 hash or an SHA-1. Ideally, you do SHA-512 these days, let's be honest. So if you set an e-tag, what the client will do is it will, next time it wants to request that resource, is it will send the e-tag along with it as part of the headers. It's almost like a magic cookie, right? If the content on the server hasn't changed, the e-tag will be the same, at which point the server can return what's called a 304 not modified. Truncate the response body, whack it straight out to the client, and just tell it, right, I can paint something I've already got in cache. Right? Smaller requests, and makes the browser basically do what it does best. So e-tags, again, dead easy to configure if you're using something like blob storage with PowerShell script. So as you're doing your upload, you can actually just set the metadata, go, oh, hash the file contents, add it as metadata. So what else do we have? Reduce the number of DOM elements. Now this is to do, obviously, with browser paint. I said I wouldn't touch on it much. 3,028 DOM elements. I mean, that's almost as bad as a table layout. Remember those days? Yeah, 20 years ago, where we all had to code for IE5? Yeah. So that's YSlow in a nutshell, and it gives us a grade, as I mentioned, which is a grade C on here. On production, it's actually a grade D, because it's 69 out of 100 instead of 71. So now that's all nice and good. What I will come to is that YSlow can also be run as a command line utility. So you can run it in a headless browser. As a result, you can integrate it with something like continuous integration. And in fact, the YSlow plugin actually supports JUnit output. So it will actually produce a unit test result fixture, which can then be picked up by CI and CD. This is very good, because then we can continuously measure performance, as opposed to just running this as a one-off tool. And I will come to all of that a little later on about automating this. So that's YSlow in a nutshell. Now we move on to the next tool in the kit, which is PageSpeed Insights. Now, if you can look up here, Up in the top right, you'll see something called audits. This is a new feature that's been added as part of the Chromium engine, basically, and it's called Project Lighthouse. Previously, it used to be called PageSpeed Insights, and now it's been expanded upon to cover more things than just page performance. It now lets you run audits. And I'll zoom in on those. You can run a performance audit. How long does this app take to show content and become usable? Progressive web app, does it meet the standards of a progressive web app? Does it work offline? Does it have service workers? Those kind of things. Does it follow best practices? I mean, that and performance kind of go hand in hand, really. Accessibility, do you have descriptive alt text on your images? Do you have ARIA tags, which means that screen readers can navigate around your menu? All those kind of things. And SEO, again, tighter performance, because since 2014, Google has been penalizing any app that is, one, not mobile friendly, and two, not performance optimized. There's a reason this site on production only gets number 9 in Google's results, because number 1, 2, 3, and 4, and everything else above it, is been made for mobile, it's been optimized, and Google is subsequently boosting that above this site. And today, we are just going to run the performance audit. And this comes up with some interesting stuff. Now, you'll notice it immediately simulates a mobile phone, a Nexus 5, okay? And it'll throttle the connection down to 384 kilobits per second, okay, to test network latency as well, okay? So there are some interesting stats. Now, if I zoom in, it won't be able to show them, but Lighthouse basically pulls off some interesting performance stats, which are things to think about. A couple of those include Walmart. Oh, that one right there. Walmart saw a 1% increase in revenue for every 100 milliseconds that their site loaded faster. Now, think how much revenue Walmart does in a year. That's immediately, what, $50 million for 100 milliseconds? That's a lot. That's a big number to put on performance. I will put some smaller numbers in terms of cost on performance a little later on. Also, another good fact, 75% of global mobile users are only on 2 or 3G connections. So we're talking 56K dial-up speeds on 2G. We're talking 384 kilobits on 3G, right? We don't have, you know, those people do not have the luxury of an 80 meg fiber connection like I do at home. Right? So, and Lighthouse, again, bit like YSlow, grade 2 out of 100. This one scores even worse, 24. I told you this is a great example of how not to do things. So, first meaningful paint at 7,000 milliseconds. It takes 7 seconds to load that on a 3G mobile device. That's horrendous. There is a magic number in performance, which is 600 milliseconds. And 600 milliseconds is the time it takes for someone to press something and to get a response for the user. If it's under 600 milliseconds, the user thinks it's instantaneous. Any slower than that, and they feel there's a lag, right? And I believe the BBC has seen fall-off rates for every 100 milliseconds of about 2%, right? So think how quickly that can compound itself in terms of how much you could lose in terms of audience traffic. So, consistently interactive at 17,000, so it takes 18 seconds for you to be able to click and press everything on that website. That's atrocious. Here we go. Now we get to some interesting bits. Right, keep server response times low. This is running on my local laptop. I'm less fussed about that one right now. What I am fussed about, text compression and reducing render blocking style sheets. Now, one of these, that shadow box thing that we saw earlier, 1,000 milliseconds. Here you go. Oh, look, there it is. 1,980 milliseconds for a jQuery plugin. You're slowing the site down by 2 whole seconds for one damn jQuery plugin. That's a really bad jQuery plugin. What else? Minify JavaScript will get us another 250 milliseconds. That's nearly half of our 600 millisecond budget. If we're assuming that there's that's our budget that we can play with, that's nearly half already. Unused CSS rules. There are certain tools that can actually parse an entire page and actually strip out CSS that isn't used once it's compressed and minified. For example, if you're using something like Foundation or Bootstrap, obviously they come as enormous style sheets and you may not necessarily use everything in them, right? But the browser's still parsing them, so which again costs time. One thing I will touch on briefly is some people use what are called above the fold CSS generators. Has anybody heard about those at all? No? Okay, so the idea of an above the fold generator is what it will do is it will take the visible portion of a screen and it will create a separate style sheet just for that. And it will put that in first, and then it will load in the remaining style sheet later, okay, as an import request. And the idea is that is to improve render time, basically, for the portion that you can see when the page is first loading. Whilst noble in intent, I have a fundamental problem with them because of the number of screen sizes that we have to work with today, mobile portrait and horizontal, iPad, tablet, portrait and horizontal, laptop, desktop, because of all these different sizes, what's above the fold consistently? This is the thing, when you're dealing with different screen sizes, above the fold means a lot of different things on a lot of different platforms. So I've never seen somebody use one successfully with a multi-platform website or web app. So if you want to try and approach one, I'm not going to recommend one, of course, but if you want to look that up on your own accord, then do feel free to do so if you feel it would be relevant to what you're working on your own projects. So, all right, so we've got Lighthouse. And as I say, it can run not just performance tests, it can do accessibility ones too. And even better, Lighthouse is open source, it's on GitHub, and again, it runs as a command line tool thanks to NPM. So again, you can automate it as part of your builds and get reporting out into your CI and CD. One of the things I'm kind of getting to with all of these tools is that the idea is that as your software or your site kind of progresses forward in functionality, you should be able to measure any new features or any changes to your code should be able to be immediately reportable. And ideally, you should be able to set a benchmark where you go, okay, we're happy kind of at this level. And if something makes it fall below that, you can actually fail your build, right? That should be something you're thinking about. So we also have some more diagnostics down here. I mentioned about e-tags. Uses inefficient cache policy. Lighthouse has also picked that up. Uses an excessive DOM size. It's also picked that up. So YSlow's got some stuff in it. Lighthouse has got some other stuff in it. So they kind of complement each other in terms of measuring, the various aspects of a page. So that's Lighthouse, and that's pretty neat. And now we move on to WebpageTest. And one of the things I love talking about performance, which is costs. And I said that, Walmart basically makes, an extra $50 million for an extra 100 milliseconds. Let's talk about smaller numbers. And let's talk about, I have a question for everybody in this room. How many people have an unlimited data allowance on their mobile phone? 1, 2, 3. Wow, that's the most I've actually seen put their hands up in a room. Okay, everyone else has got capped though, right? Maybe 10 gig, 20 gig. Okay, right. File sizes, request counts matter because there is an intrinsic cost, okay, to your user for using your service, and that comes out of their data allowance. So I'm going to show off a lovely example of this. I'm going to load up the Formula E site. Now, what's great about this is it also lets you test different environments and different locations around the world. So you can test on Android, iPhone, iPad. You can test from North America. There are selection options for South America, Europe. We've got Amsterdam on there, and we've got one in Africa, which is Mauritius. We've got the Middle East and Asia. So you can test on a really global scale how your site measures up. And obviously, ideally, if you're doing stuff in the cloud, obviously you would kind of have like distributed, content nodes and things. So, but this allows you to actually measure what that's like from the other side of the world. So, very useful for the Formula E website in particular. We use this a lot. So I'm just going to test this from the default option, which is Dulles in Virginia, and that's going to test with a Chrome browser, and it's going to test Android and iOS. And now this does pretty much the same thing as the network tab does in Chrome DevTools, right? Gives you kind of a waterfall breakdown, tells you how long things took, and gives you the various paint times. It also runs the runs the test, as I say, 3 separate times. One on desktop, one on Android, one on iOS. So there we go. And this is where it gets fun, because there's this nice little tab up here, cost. How much did that, oh, hang on, bytes in, 0 kilobytes. Oh, first view error of 405. Oh, hello, you opened something, didn't you? I reckon that's a cookie policy, isn't it? Let's check that out. Rerun the test. See if that goes. Come on. And because obviously this is a sports website, it's lots of high-res images. It's very expensive on the day to download. And it's still not doing it properly. Hang on. 1 second. Right, I'm going to try that again. All right. And now it wants me to do a capture. Oh, joys. What have you got? Let's see if this works now. What's interesting about this as well is that that's really odd. It's refusing to do. It says 0 kilobytes. Okay, I'm going to try and think of another one. Actually, I know what to do. I have another good example. It's fine. Plenty of projects I've worked on. Universal Music, Japan. 26 record labels, 2,500 artists. I helped them upgrade some .NET features and some performance improvements as well. Let's see if this one's going to work any more effectively. Oh, one of the interesting things I was going to mention about a number of the tools that I've mentioned, a guy called Marcel Jaron, who I believe used to work for Yahoo, really good front-end expert, and was involved with YSlow, has firstly taken over the administration of YSlow, and secondly has created a number of command line tools for NPM, basically, both for Lighthouse and for WebpageTest. So basically this is a demonstration of most of his handiwork, plus some other bits. So here we go. Now we're getting somewhere interesting. Right, if we zoom in, we've got bytes in, 2,524K. All right, so that's 2.5 meg. The bit I love is the cost section. This is tied in. It's called whatdoesmysitecost.com, and it tells you on both monthly contract and pay-as-you-go how much it costs someone on average who has more than 500 meg of data available in a 30-day period, how much it costs around the globe. So that page, 30 cents in Canada. Now, Universal Music have got a very good CDN and a very good caching policy, so obviously that's just a first load, okay? Subsequent loads will obviously be less. However, that's still pretty pricey. And in Japan, the main target audience, oh look, it's 20 cents to access that. And that's even on a mobile device. That's because everything still loads. So, and on prepaid, the picture gets actually not that bad. 20 extra products, that's 2 page views. Look at the products. 3, add to basket. 4, homepage. 5, search. 6, view product. 7, add to basket. 8, billing, shipping, checkout, thank you very much. 12 page views. If you haven't got e-tags or expiry headers set up properly, that's just cost you, if you take that example, $3 just to go shopping. And that's before you've actually paid Amazon anything for actually buying anything. It's a cost that you have to think about. That's why this stuff is so important. It's so that your users can get the absolute best out of their plans. Our job is to make sure that we impact on their data usage as little as possible. So, all right, so that's WebpageTest. Again, NPM module available as a command line tool and can be integrated into CI. So we'll be demonstrating a nice little Docker image that I've got, which isn't quite there yet, but will be going on GitHub very soon, that shows you everything that you can do with it. So, all right, so that's that. Now we move on to the fun stuff, JMeter. Now, JMeter, being made by the Apache Foundation, unfortunately has the distinction of being written in Java, which means it sucks on Windows. So I'm going to quickly switch to doing this, duplicate mode, there we go. Right. All right, so this doesn't really look like much at the moment. We obviously have a thing called a test plan, and this basically gets saved as an XML file. I'll come back to that a little later. So we're going to go add, and we're going to create thread group. So we can, number of threads, users, so we can pretend to be anything from 1 to infinity number of users, should you really wish. Ramp up period. This is if you want to simulate, let's say, a gradual increase in load, say over 5 or 10 minutes, or whether you just want to slam the thing straight away within 1 second and go, right, I want 200 people to simulate an immediate hit, like, almost like a DDoS to yourself, basically. And loop count, how many times is it going to execute the set of instructions that we're going to set up underneath? So I'm going to start with 200 users and a loop count of 50. So that it will total 10,000 separate requests, all right? Now, we're then going to add a sampler. Now, this is where JMeter really comes into its own. It doesn't just do web requests. It does FTP requests. It does ODBC, well, JDBC requests. It does LDAP requests. It does SMTP. It does TCP. It does every kind of network traffic you can imagine. It's open source and it's got a fully pluggable architecture. So it can handle just about anything you want. If you really want to hack off your network admins, try the TCP one. But yeah, you can virtually load test any type of scalable structure that you like using this tool. And it's free, which is amazing. It just sucks that it's written in Java. But that does have its advantages I'll come to later. So today we are just going to focus on the HTTP sampler just to demonstrate what it's capable of doing. And now what's great about this section is, of course, it supports being fully pluggable. It also supports the full gamut of HTTP request methods. So you can also, there's a plugin where you can actually load CSV data in or XML data from a source, okay, and do variable swapping to load test things like REST APIs. This is where it gets interesting for the web API people. If you want to load test that, JMeter can do that as well as just regular front-end requests. So we are just going to demonstrate a really simple HTTP www.formulae.com, and I'm just going to go for the root. And what's great is then we add what's called a listener, and you can output this in all sorts of different things. So let's have a look. You've got graphs, you've got simple data writer, summary reports, results in a table, so you can put this in CSV or JSON format or XML format or just have a pretty graph. We're just going to go with the pretty graph today, basically. But again, you can get all this stuff outputting, again, as part of your build artifacts. So if you do want to do load testing as part of your CI, you can. Even better, JMeter runs on a master-slave kind of system. So what you can do is actually, if you want to run higher load tests, then you can actually throw the XML manifest, which is what this saves as, throw that over to a slave agent, and subsequently, instead of just testing 10,000 times, I can test 100,000 times, because JMeter slaves are available in both the Azure store and the AWS marketplace. So I can rent, on demand, extra load testing capacity for cents, get all the reports centralized, and basically pretend to have 100,000 or 500,000 people slam my website and really test my infrastructure and my code. So, pretty neat. Let's quickly just add that graph in there, and we'll see what this is going to come up with. Obviously, I don't recommend running the test in the actual UI because that means you're using foreground threads. So this is merely for demonstration purposes. Always try and run your tests using the command line facility. So it'll be better memory managed. So off we go. No, I do not want to save. And that went very quickly. Excellent. Oh, maybe I forgot to actually set the, I forgot to set 30 seconds, that's why. Right, so that is all the requests starting to be slammed through to the Formula E website, and we've got an average time. I suspect this is more to do with Wi-Fi than anything else, but average response time is 4.9 seconds. That's not too hot. Yeah, the throughput gives you an idea that this is actually quite not handling it too particularly great. I think it's more the Wi-Fi than anything else. So, and number of samples, oh, hang on, no, sorry. There we go. Number of samples, so we're about 10% of the way through the test at the moment. And you can see it's starting to kind of flatten off a little bit, but obviously that's particularly not great. So, obviously you can then save that to a file, build artifacts, continuous integration, it all gets tied together quite neatly. And we're just going to stop that, and this is the bit where it always crashes, so I'm just going to manually kill it. There we go. So, yeah, it's Java. Yeah, that's all I have to say about that. So, all right, so we've gone through all the front-end stuff, gone through JMeter for load testing, and lastly, we're going to show off Miniprofiler, which is this bad boy down the side here. And Miniprofiler is brilliant. It's got support for the MVC frameworks. It's got support for Entity Framework 5 and 6. It's got support for RavenDB, and it's built by the lovely people at Stack Exchange, which means it is actively developed, supported, and available on NuGet under, I think it's an MIT license. Anyway, I mostly work on Umbraco websites, and since Umbraco 6, Miniprofiler comes bundled, which is why I'm demoing this. So this is where it gets really handy. Gives you a view by view, partial by partial breakdown of how long each one took to run. So we can see The overall request took 972 milliseconds. Now, bear in mind I'm running in 32 gigs of RAM here with an i7 and an SSD. Even that's too slow, right? Mini-Profiler was amazing when working on the Formula E website because I loaded it up on my laptop and, again, similar specs, 4,200 milliseconds to run. Mini-Profiler was instrumental in us bringing that down, and I'll get to that in just a minute. So this gives you, as I say, a view-by-view breakdown. And what's even better is you'll notice the red SQL section on the right there. It'll also tell you how many queries are being run and how long they take as well. So you've got a full, proper insight into how long the actual render is taking throughout controller, action, view, and lower down commands as well. That's pretty damn cool, right? So what I will demo at this point, here we go, we've got duplicate readers. Now I'm less fussed about those, this is a CMS after all, and also SQL Server's smart enough that if it's seen a query before, it'll cache the query plan, which means the execution is just instantly faster. So, but obviously you can get an idea of exactly, it's telling you kind of where it's actually being set up. See, execute page hierarchy, execute, get main image path, setup node. So you've got a kind of stack trace that tells you where that query is kicking around in your system. And it then gives you the actual SQL itself. That's pretty neat. So, now one thing I will talk about at this point is the reason why this thing is so slow. Who uses the keyword dynamic in C#? Nobody. Fantastic. I'm so proud of all of you. The reason is that 4,200 milliseconds from the Formula E site I mentioned, one carousel, 5 slides, using dynamics on its own, 3,500 milliseconds to render, because dynamic with an object, in CMSs it's kind of useful because obviously you have to set up properties and things and you don't necessarily have strong typing. You do now in a lot of them. Dynamic is kind of a lazy way of getting a nice API for people who don't necessarily have Visual Studio and want to kind of code in the browser, which you can do in some of them. And that's nice, but it's a performance nightmare. Because basically, it's, when you use the dynamic keyword, it's backed by an object called dynamic object. It's a class in system.core. And when you have an implementation of that, what happens is the runtime goes, it does try, get, and then member, field, property, it uses reflection to basically kind of iterate over catch. What do we know about catches? Even if you don't declare an exception variable, one is still thrown. Exceptions are very memory heavy and they take ages in execution time, and that is why that render time is so slow, because of dynamic, basically. Not only that, it's then got to infer the type out as well. So don't use dynamic. That's going on my gravestone. Do not use dynamic. If you do, I will hunt you down. I promise you. After removing dynamic, when I say don't use dynamic, I mean it with conviction, please. So, yeah, Mini-Profiler was instrumental in being able to spot that and tell us where that problem was and subsequently be able to remove it. So, Mini-Profiler, brilliant. So, those are the tools we use to measure the various different points. Now, obviously, how do we improve? Let's go back to our slides. How to measure. Lovely. Right. How do we improve the various different parts? And there is a lot here. These slides will be available afterwards as well to give you kind of summary notes. So, because this list is long, it's longer than Robert Mueller's subpoena list or longer than the list of women that Donald Trump has sexually harassed. So we start with the HTTP request, both HTML and API. Make your requests as small as possible. Use cookie-free domains. Move stuff to CDN and blob storage. It is so cheap, it is ridiculous, right? Use it. gzip and deflate static resources. I haven't covered compression yet for a good reason. gzip and deflate are built into every single major browser, so you can actually gzip your assets kind of at build time and deploy them. That's fine. For static resources. For dynamic resources, there's a vulnerability. If you serve gzip or deflate content in, let's say, an API or an HTML page, and you do so over an SSL3 connection, then you basically fall victim to this, called crime or breach, which is a combination of vulnerabilities. Basically, it can use the compression algorithm to break open your SSL3 connection, at which point someone can sniff sensitive user information, cookies, authentication tokens, JWTs if you're using an API. Serve dynamic resources at your own risk. If you're working on things like enterprise, internal, intranet-only apps, fine, serve it up. So although having said that, with dynamic content, because obviously it's doing execution stuff, you may find that compressing it actually costs more in terms of server render performance than it's worth in terms of bandwidth and traffic. So use basically at your own risk and as your circumstances dictate, all right? But for static resources, there's absolutely no problem at all. gzip and deflate your, gzip or deflate your content. You add that as a response type as well on your objects in blob storage, and again, they'll come out as headers. So all works quite naturally. So enable caching on static resources. I've already covered the headers, the expiry header, and the e-tags header. I haven't mentioned cache control, which is an interesting header because sometimes that can be misinterpreted by routing and proxy devices, especially in company networks. Even if something says cache control private, then that can actually get misinterpreted and the network can effectively cache something which you said you didn't want cached or has potentially expired. So I've yet to come across an environment where I've seen cache control really work properly. So generally speaking, you can get away with the first two just fine without having to rely on cache control. All right? So reduce asset size. Minify your CSS and JavaScript. That's an obvious one. Don't lazy load unless you know it will work reliably. Obviously, a lot of people are now building things like mobile apps and stuff. If you're lazy loading your JavaScript, that's nice, but there's a problem in that if I happen to lose connectivity on a mobile device, what happens if that JavaScript doesn't load? You get effectively a mobile app yellow screen of death, or worse. It's better to bundle everything up and ship it all as a single resource. Because then what you can do is when you make your API call, if that error's fine, show them a nice attractive error message saying, sorry, you're offline. But make sure all your things like views, essential stuff and things like Angular and React and so on and so forth, make sure those are all bundled together. So, oh, wrong way. Use an in-memory cache to boost speed when the system isn't quite as fast as you want it to be. Don't be afraid to use things like RavenDB, well, not MongoDB, let's be honest. RavenDB, Memcached, Redis, all those kind of tools that are available as kind of very cheap memory, kind of key store type stuff. Use them. And I'll give a great example of this, which is back to my old alma mater, Universal Music. So I mentioned, obviously, this has got 26 record labels, 2,500 artists, everything from K-pop to J-pop to Lady Gaga and Justin Bieber. 3 million hits a month. And this section was particularly problematic because there were, at the time when I was working on this, there were 164,000 content nodes. And these views had to basically pull out something in the order of about 5,500 news nodes from across the entire site and then rank them in date order and share the top 3 in those columns, right? That was a really heavy and really expensive query with the APIs that we had. So what we did is on site boot up on application pool, we had a kind of blue-green deployment mechanism. We had 3 servers, and we would push the update to one server, and there would be a background thread that would crawl the site, run that query for us, very heavy and very expensive, and then it would gather those objects up, dump them in RavenDB, and then that's what would populate that. Now, obviously, we had a load balancer in front of it, which would go, oh, if that server's not responsive in, say, 5 seconds, it would immediately just fall over to another. So while that was spinning up and doing all that background thread work that was very, very heavy, it took about 45 seconds to actually run the entire index. Very heavy query. The other 2 sites were still up. And basically, when our index was rebuilt, then obviously our main server was fine. We could then deploy to the other 2, because then that would handle the traffic, whilst the other 2 were obviously rebuilding their indexes too. So, and then we had a pub-sub mechanism as well. Every time there was a new news item published, it would go into the RavenDB as effectively a master, effectively our master cache, if you will. So don't be afraid to use those kind of tools. They are available for these purposes. I will add one caveat emptor, which is if you're going to use something like Varnish, which is a reverse proxy. Anybody come across Varnish? No? Okay. So it sits in front of your servers, and it can actually cache HTML and API responses. This can be good. However, if it's misconfigured, it can result in problems, which is what Formula E had. They had a misconfigured Varnish server, and it started leaking. User-posted data had actually been persisted into the Varnish cache. So other people started seeing each other's usernames and passwords. Yes, we had an official data breach. £25,000 fine, and I got the guy's job because he promptly got dismissed. So if you're going to use it, make sure you configure it properly. Otherwise, it could cost your career and your business, as one person learned the hard way. So, and we go back to our last bit. Send 304s, I mentioned, if you know that the resource is already there, right, then send a 304, truncate the response, and push it up. Oh, there is one thing I haven't covered today, which is the rise. A lot of these techniques are obviously relevant both to HTTP 1 and HTTP 2. Okay, there's some stuff around this minification in particular for JavaScript and CSS. HTTP 2 is the brand new version of HTTP that only got ratified 4 months ago by the IETF. Okay? It's got a great new little feature in it in that it will multicast connections. And what this means is that, because previously when you're downloading resources will be downloaded one by one in that kind of waterfall fashion as the browser is, want to do. But each resource has its own connection. It gets opened, the request headers and body get sent, the response headers and body come back, the connection gets closed, and so on and so forth. Okay? Windows XP used to actually suffer horrendously from a limit on the number of connections that could be simultaneously done. It's an absolute nightmare. But HTTP 2 allows you to open one connection, make multiple requests, all through the same connection, and then when it's all finished, close it off. This is very good, but sometimes this demo is a little unreliable because of the network, and I'm not entirely sure why. So, HTTP 2, there we go. All right, so on the left is images loading using HTTP 1, one by one. And I'm hoping this one actually works. There we go, yeah. That's fine, there we go. And improvement of, let's see, what is that? 9.82 seconds versus 2.39. 75% performance optimization just by being able to multicast. Now that is impressive, but I still believe that you should be looking to make those requests A, as small as possible, and B, as infrequent as possible. So the techniques I have discussed still apply. Right. So, all right, so we've talked about obviously how we measure, how we improve, and, oh yes, server render I've already mentioned, JMeter for load testing, and mini profile. I will say it again, do not use Dynamics and .NET. If you know anybody, spread the word. If you know anybody that is, spread the word, tell them, show them this. And we move on to monitoring, because obviously performance is a never-ending game. Obviously, our sites and our software are always evolving. We're always adding new features or improving them. So we want to be able to continually monitor this stuff. I've mentioned all the tools today with the aside of mini. But keep at it. Install tools that will do application monitoring for you. Has anybody come across New Relic? Excellent. New Relic, for those that don't know, works for Node.js, Java, and .NET. In the .NET space in particular, it installs a global HTTP module on your server, and then it can basically tells you how long the network traffic took, how long the server actually took to render on given execution path and on given URLs, which is amazing. And give you the entire response time as well. It even tell you if there are any issues with things like different platforms as well, which is phenomenal, the type of insights you can get from New Relic. I think they still do a free option. If they don't, it's still worth buying. It's my absolute go-to tool of choice for large, high-scale sites. So, in fact, I will tell one story about New Relic, which is whilst at Universal Music Studios, we had a custom AngularJS app which was using SignalR both to deliver data from RavenDB, powering the e-commerce section of the Universal shop, and it was using Angular for the views and SignalR for data and views, which was very interesting because SignalR is a kind of bus, it's a two-way communication. And we discovered that one particular page, for absolutely no reason whatsoever, was taking about 3.5 seconds. Quite a long time. And New Relic was actually matching up with this and showing us that the server execution time was actually 3.5 seconds. And we were going, well, why the hell is this? And I was wondering, is it the dependency injection container? Unity, because that occasionally can be quite heavy in memory. I was wondering, is anything to do with that? No, it's not. I went and dug in to the actual JavaScript in the page. And because of the way SignalR works, it obviously keeps a connection open, right, until you actively close it. So what happened is the connection had been opened, the request had been made, the data would come back, then there was a JavaScript callback being run with the data thrown into it, and then the connection was being closed. I reversed those two lines, closed the connection, then ran the callback. Server render time dropped to 200 milliseconds. It was a JavaScript paint problem. Data population trying to populate the JSON into AngularJS. I threw it to our front-end developer, and I went, it is not a .NET problem. So, and New Relic helped me find that, basically. Gibraltar Soft Loop, who has the misfortune of working with WinForms or WPF these days still? Nobody? You? Oh, you poor people. Okay, so Loop is based on a tool called PostSharp, which is an aspect-oriented programming framework for basically environments where you don't have one, okay? So it's an amazingly clever tool because it actually does something called IL interweaving. So what you do is you create aspects, like attributes in MVC that you would create, that will change the response output or the method output. You can create your own aspects using PostSharp, basically, and then what it will do, once your code is compiled, it will then delve in there, take your aspect, and actually wrap that around your other code. So it's an IL interweaver. The guy who makes it, Georg Vater, is based in Prague. It's phenomenally clever. Seriously, I think this guy lectures at universities as well. If you ever get the chance to go to Prague and have a beer with him and his team, do, and take a notebook, because you will want to make notes. He is damn clever. Loop is based on that. It basically allows you to add logging attributes to methods, so you can say, I want to trace how long this one's taking. It'll also give you platform and browser-specific information as well, and it all gets backed up into the cloud as well. And the guy who runs it is a mate of mine called Kendall. He's very nice. So, and he really wants to be British. He keeps coming over and drinking our tea. So, and lastly, file, new web application project. There's a tick box. Azure Application Insights. It's basic. It tells you things like response times, but it is handy. It's a good little canary in the coal mine. I still get emails from a couple of projects where I'm on someone's Azure subscription, basically, because they're using it to check that their response times are still up to par. So, and occasionally when there is a slowdown or something, I still get an email. So it generally resolves itself within about 30 seconds, so I generally don't pay any attention to them. So, and obviously with Frontend Performance, we want to be able to continually monitor. I'm going to show off the working, well, I'm going to show off the kind of outline of a Docker image that I will get onto GitHub soon, I promise. I've been saying that for quite a while now. So, but it will be soon. Obviously, YSlow, there's a bug in YSlow if you send it multiple URLs. The XML of the JUnit actually has multiple root nodes, so I'm hoping to patch that soon. We obviously have PageSpeed Insights and Lighthouse, and JMeter and WebpageTest all can be run as node modules. And I'm now going to jump into that. So this is a Docker image that's based on OpenJDK because Sun Oracle are a pain in the neck about licensing the official Java runtime on Windows Server Core, because Oracle and licensing, when are they not a pain? So let's get straight in. We download Jenkins, CI. Other continuous integration servers are readily available. ThoughtWorks, Go, TeamCity, pick one. I'm using Jenkins because it's free and I know how it works. So then we install standard .NET Framework 4.5 and IIS and the Web ASP features. Then we go down and we install MS Build Tool so that we can compile a web application project. And then further on down the page, we go, we've then got install NuGet right at the top there, then install the web target, then we install Git, then we install JetBrains static code analysis, so that does a couple of things like checking the performance of your actual compiled code. That's kind of neat as well. If we're going to measure performance, we might as well throw something like that in there. Other ones available would include things like Ants, Ants Profiler by Redgate, that you could also use that. And then we've got, right down here, we've got NUnit, XUnit, and then this is where you install the tools that I've shown you today. You install JMeter, YSlow, as a great tool for Azure blob storage called AZCopy, which is just a command line tool that lets you throw files at an executable and it will just upload them to blob storage for you. So again, can be integrated directly into your build environment. If you want to set the metadata on it to use the headers and stuff, I personally would recommend using PowerShell instead. So then we install a couple of extra goodies. We install Chocolatey. Has anybody come across Chocolatey before? A couple of people? Okay, Chocolatey is a NuGet package manager for desktop software. So it installs exes and MSIs with dependencies. Bloody brilliant. A bit like NPM, really. So that installs Chocolatey, because then we start installing the supporting tools around things like YSlow and Lighthouse. So we install Phantom.js to begin with. So that's our headless browser that works with YSlow. Then we install Yarn, because Lighthouse actually comes as a Yarn module, which is Facebook's version of NPM. Because, of course, open source software is about going, oh, yeah, that doesn't quite work how we like. Let's build our own. Anyway, then we install Lighthouse, and then I've got a gist somewhere kicking around which has got Lighthouse config that will turn the JSON into JUnit compatible XML as well. Then we install WebpageTest, And then to actually run these scripts, it's quite simple. Is it that one? No, it's this one. Nope, that's not it either. Here we go. Perfect. So yeah, so I'm planning on turning obviously like a build script for PowerShell. So the idea is that you basically pull this Docker image, throw into it one web application, tell it the URL that you're actually deploying it to, and it will do that with MS Deploy. And on top of that, it'll then start running all your automated tests for you. That's kind of where I'm trying to go with this, so that you can just pull something down off Docker and within 10 minutes you immediately have all those reports run for you on your current project. So, as I say, still work in progress. When it's finished, it's going on GitHub. So, but to run these tools, obviously Phantom.js, you then throw in the yslow.js, which was downloaded in the previous, in the Docker file, throw it a URL, and then put just simply -f JUnit. Hey presto, out comes a JUnit XML file. Perfect, right? Next, Lighthouse. Again, throw it a URL and then put /output JSON, CSV, or HTML. I'm going to be adding JUnit to support to that shortly by transforming the JSON, basically. And WebpageTest actually only does it in text format at the moment. Again, I'll be providing a transformation facility for that. Throw in a URL, and the documentation for all of these things is all over the NPM pages for them. So if I go WebpageTest and Lighthouse. So for the WebpageTest, now there's something interesting here in that WebpageTest will only work with public URLs because it's a hosted service, okay? So you'd kind of want to run that against production, or ideally you'd specify a QA site which you then turn robots off so search engines don't find it. There is a tunneling tool if you insist on running it on kind of in-house enterprise stuff, basically. There's a tunneling tool for Node where you can set up effectively a URL that will then tunnel through to your local machine. And I've been trying to find it, and I can't for the life of me find it. But when I... Sorry? It might be related to that, and that does sound familiar, so maybe. But yeah, basically, if you want to test internal stuff using WebpageTest, then you can funnel it through there and then run WebpageTest against it. It's kind of cool. The documentation for this stuff, the commands, there are so many options. Here we go, of this stuff. How many runs you'd like to do. Would you like to capture the video? Would you like to keep it private for your own in-house company stuff? I'm not going to go through all the options. They are very extensive and they are well documented, basically. And lastly, Lighthouse. Lighthouse's options are fairly straightforward. Simply specify output paths and what format. You can also specify things like throttling, so you can actually be really specific and say, oh, I actually want to test this on a 50K connection, or a 2 meg connection, or an 8 meg connection. You can be very, very specific with the kind of testing that you can do here. And yeah, there are all your individual options there. So they are the tools, they are how you improve and how you constantly go on and measure. So after that, that's it. Any questions? Apart from for the fat man up there? No? Okay, great. Thank you very much.